Alright, Newton's third law of motion for lesson 4, chapter 2. Vocab slide. Newton's third law of motion states that when one object exerts a force on a second object, the second object exerts an equal force in the opposite direction on the first object. Force pair are the forces two objects apply to each other. Momentum is a measure of how hard it is to stop a moving object. The law of conservation of momentum states that the total momentum of a group of objects stays the same unless outside forces act upon it. So Newton's third law again states that when one object exerts a force on a second object, the second object exerts an equal force in the opposite direction of the first object. So force pairs are two forces that apply on each other. You can never have just one force, which is partly true. On Earth it's for the most part true. Even if you just drop something, if I just drop a book, there's still air resistance fighting gravity. So gravity's our force down, air resistance is our force back up. For the most part, you're always going to have forces in pairs. An action force is the force that you apply on the initial or the initial force. So the force that you apply or the initial force. A reaction force is the force that's applied back by the object that has been acted on. So in this case, our action force is the air rushing down. Our reaction is that the balloon's going up. We have this guy pushing into a wall, so that's our action force, and the wall pushing back, that's our reaction force. Our rocket down here, we have action. Our rocket fuel is being pushed out of the thruster, and our reaction is that the rocket goes in the opposite direction. So momentum. These little fun desk items are a great example of the conservation of momentum. Newton's third law of motion. Momentum is a measure of how hard it is to stop a moving object. The symbol for momentum is P, and it is measured in kilograms times meters per second, which is a result of the formula for P. So momentum, or P, is equal to m times v, which is mass times velocity. Therefore, momentum is equal to mass times velocity, where mass is measured in kilograms and velocity is measured in meters per second. So we would write that as kilograms times meters per second, or kilograms times meters per second. That little star is the only difference there. Momentum. If mass increases, momentum increases. If velocity increases, momentum increases. So if you increase either one of those two things, your momentum is going to, either one, when I say either one of those two, I'm talking about mass and velocity, your momentum is going to increase. If you decrease mass or velocity, your momentum will decrease. Either one or both. So here's our graphs for that. We have mass on the y-axis, momentum on the x. So as one goes up, the other one goes up. Same with velocity. Velocity is on my y, momentum's on my x. As one goes up, the other one goes up. As one goes down, the other one goes down. So those are directly proportional. So momentum practice. What is the momentum of a 12-kilogram bicycle moving at 5.5 meters per second squared? You write what you know. You find your formula. You plug in your variables. You get 12 kilograms times 5.5 meters per second. You solve to get 66 kilograms per meter second squared. Here's your next practice. 55-kilogram woman has a momentum of 22 kilograms times meters per second. What is her velocity? Again, write what you know. Write your formulas. You're just rearranging these like we would in an algebra problem. You plug in your variables. V is equal to 55 kilograms divided by 22 kilograms times meters per second. You solve to get 2.5 meters per second. Our last momentum practice. A semi has a momentum of 24,500 kilograms per meter second, or times meters per second, and is traveling at 70 meters per second. What is the semi's mass? Again, you write what you know, you write your formula. So here on this slide we have all three types of the formula. You plug in your variables, your values for your variables. We have 24,500 kilograms times meters per second divided by 70 meters per second. And when we do that, we end up with a mass of 350 kilograms. The law of conservation of momentum states that the total momentum of a group of objects stays the same unless an outside force acts on the objects. The outside force is usually friction. So there are two types of collisions. We have elastic collisions. This is where two objects bounce off each other. And inelastic collisions is where two objects stick together after contact. What's easiest for me is to think of elastic. Something that's elastic is really bouncy or rubbery or springy. So I think of elastic as bouncing. Momentum is always the same before and after a collision. Momentum also transfers between objects. So if you replace these things with the silver metal balls that sometimes you see on the desk as little toys, this is a great, when we drop the M here, that momentum carries through all the way over here and hits our other M out, and then it swings back and forth. And I'm pretty sure we've all played with some of those. So here we have an elastic collision because it's bouncing off. So we have our lighter circle coming over, or I guess it's a cue ball. The cue ball coming over, it hits the 8 ball. The 8 ball in the after picture takes all of the momentum and goes. So the momentum, all of the momentum in the cue ball in the before picture is transferred to the 8 ball in the after picture. This is an inelastic collision, so we have our piece of chewing gum, we can call it, is going towards our white ball over here. After it strikes the white ball, they stick together, so that's our inelastic collision, meaning they stick together, and all of the momentum that the bubble gum here has is transferred to this system now that they're all one thing. This is one thing now, so it has the same amount of momentum that just the bubble gum had up here is now in both of those things. It's transferred to that system. That will do it for the lesson 4 notes.